So at last it's time to take a look at more programmatic access to MongoDB through the Node.js driver. And what I mean by that is we're going to begin to look at using the driver for applications that respond to input and query MongoDB accordingly, rather than simply passing along some sort of static query document or projection document that we've hard-coded in. So what I'd like to look at here is a simple application that will take command line parameters and query MongoDB differently depending on what we've specified as options on the command line. This is the type of thing we might do in a web-based application or some other type of application, but allows us to focus on the driver and its interaction with MongoDB without too many additional packages and details. One additional NPM package we are using here is command line args. And this gives us a nice, convenient way of dealing with arguments passed to our application on the command line. So here, we're requiring that package. It's also in the package.json file that will accompany this handout. And here we'll create this command line args function that will allow us to pull in the options from the command line. Before we do anything, let's try to run this. Now, our attempt to run this prints out this usage message saying, first two options below are required, the rest are optional. The intention of this application is that we can actually pass a few arguments into this application and use these values we've passed in to create queries to MongoDB through the driver. Let's go see how options are parsed and where this message comes from in the app. Okay, so what I've done is written this command line options function, and it uses the command line args function that we got from our import of the command line args package. Now, what we've done here is defined the command line arguments that this particular application will accept: first year, last year, and employees. These we will use to specify a range of years or founding years or starting years of a company with which we'll query our company's collection, and a number of employees value. We've also specified a one-letter alias for each of these to make it more convenient when constructing a call and passing in these parameters. Note that what we'll end up with here is something much like what we saw with Mongo import, where we specified the database and collection where we wanted to import our company's data using -d and -c respectively. In this case, we're looking at designators for the first year, last year, and employees command line arguments. Now, this method of constructing command line arguments is defined by the command line args package. For more detail on the semantics of this, I encourage you to look at the documentation within the NPM repository. The last thing I'll mention here, though, is that we are stipulating that each one of these command line arguments should be a number. And the reason for that is because when they're typed on the command line, even though we may be typing a series of digits, we could conceivably pull them in as a string. Basically, this tells the command line args package how to parse them and what type they should be cast to in order to ensure that we can use them as desired within our application. This command line args call gives us then an object on which we can call methods. So this constructor creates a CLI object with a parse method. That parse method then will parse everything that we've typed in on the command line. Let's go actually enter some command line parameters. So instead of just node app.js, I'll actually enter a value for first year. Let's say 2004, value for last year, 2008, and a number of employees. And for this, let's do 100. The intention of this application is that it's going to query MongoDB for all records where the year in which the company was founded falls in the range 2004 to 2008, inclusive of those two endpoints, and where the number of employees is less than 100. Before we run it, let's go back to our application and just finish off this discussion of how the arguments are parsed. The result of having called parse is passed to this options variable. Now, options is merely an object, and there will be one field created within that object for each one of the values specified here. So for first year, last year, and employees. Even though we're just using the alias in each of these places, the way we'll reference each of those values in this options object is by the full name. So this line here enforces the requirement that first year and last year always be present in the command line args passed to this application. If they're not, that's when this usage message gets printed out that we saw here. The reason that was printed out was because there was no first year and there was no last year from this call to app.js. Finally, if we make it past this, then I simply return the options object. So where does this call happen? Happens right here. Options will be set here in the global context, and then I go and make my connection to the database. Note that I don't bother making a connection to the database until this function returns this function will only return if this condition does not hold and we don't need to print the usage message and then just exit. If we get past this check here, then we'll return options, and we know we've got a good set of command line options and can go ahead and create our connection and get started with what this application does. Okay, so now let's go ahead and run it. And what I'm going to do first is just demonstrate that check. I'm still getting my message. Now what if I just do E? Nope, not good enough. How about if I now do a first year and a last year? And there we have it. I see results, and in fact I've got almost 8,000 results. Let's go ahead and add that employees parameter now. And now we can see we've significantly reduced the number of results. So what's happening here is we're doing a query using these values that we've entered. Again, specifying a range on the year in which the company was founded and a number of employees cap. So looking for all documents that match these constraints. And we're printing them out here, or at least we're printing a projection of them out here. I'm also displaying what query was actually sent to the database. You can see here that founded year is being queried for a range, 2004 to 2008, inclusive of those 2 years, and number of employees greater than 100. I actually misspoke earlier. I believe I said this value specifies a cap on the number of employees. In fact, in this particular application, it specifies a minimum number of employees. Okay, so that's why we're seeing the query come out the way it did here. All right, so now let's go back into our app and take a look at how all this works. There's a call to a function called queryDocument here, and note that we're passing those command line options, that object that contains all of our command line options or command line arguments. And what we get back is this value query that we end up passing to find. Here, we're building our projection document and doing so statically. We'll look at a couple of examples a little bit later on where we build a projection object programmatically as well. Okay, so we pass the query and the projection here to find, making the call synchronously, just getting the cursor back. Okay, and then we're tracking number of matches here. Now, before we go any further, let's go take a look at how our query document is being built. What's happening here is that I'm constructing a query object here. I'm doing so using the options that were passed in on the command line. So I'm accessing this options object that was passed in. Remember, we passed it in to the query document function. You can see here that I'm building the query object by specifying founded year. If we take a look back at our Facebook example, we can see that founded year is a top-level key. As you might imagine, specifies the year in which the company was founded. So what I'm doing then is I'm saying, okay, founded year in my query object that I'm building up here has a value that is itself an object. Okay, remember in the parlance of JavaScript, using this type of syntax, or this type of syntax here, which amounts to the same thing, is how we go about constructing objects. These things are objects in JavaScript, and these are the things that we are interacting with, or that we call documents, in a MongoDB context. It just turns out that because we're working with JavaScript, these objects end up looking a lot like documents that we interact with through the Mongo shell, and generally when we talk about MongoDB schema. Remember that JSON actually is an acronym for JavaScript Object Notation. This object that we're constructing as the value for founded year, this object or document that we're constructing as the value for the founded year field, has two fields within it. The key for the first field is this $GTE. If you'll remember, that is a query operator. And the second one is $LTE. By stipulating as the values for each of these keys, the first year and the last year respectively, we construct this range right here. And note that this is one reason why the query language works the way it does. So I can specify a field and then use query operators to specify a range. The next piece here in this query document function is where we're dealing with the employees parameter passed here, whatever that value is. Now remember that we don't need to specify an employee's value. Here, the first thing that we're doing is we're checking to see whether this key, employees, is in fact in the options object that was passed in. This is the syntax we use for checking for the existence of a key in an object in JavaScript. We use this in operator. If employees is in fact in options, that means that on the call to this run of the application, the user did in fact specify a value for employees. So we need to build that into our query document. In building it in, we're going to use the GTE operator, and we're going to access that employee's value much in the same way we did the first year and last year. We're using a different syntax here, though, in order to set this property of the object, or in order to assign this value to the number of employees field within this object. The reason why we can do this is we've already got this query object that we constructed here. JavaScript allows us to use a dot notation to reference properties of an object or field names, and I can use an assignment statement to specify that number of employees should have the value that results from constructing this object or document. Now, I'll point out that the only reason why we're doing this as a second step is because employees is optional. We may not, in fact, have a value here. If we did, we could do something like this and be done with it. Now, the problem here is that I've actually put this in the wrong place. It's not actually part of the embedded document for founded year. Rather, it would go here. And now, the end result of doing this would have exactly the same effect as this. And we could set up our query document this way if we were guaranteed that employees would always be there as a command line argument. It's not, and I did that on purpose so that I could show you this alternate syntax. But I want you to understand that the end result of doing this followed by this, assuming there is an employee's value passed on the command line, is exactly the same as if we had constructed our query object this way. Let's run this both with employees and take a look at the object that gets constructed. So founded year with that nested document, number of employees with its nested document just specifying one end of a range. Okay, and then take a look at a run without specifying employees, and we can see that all we have in our query document is a range for founded year. Okay, so now let's close off our discussion of this application by just running through what's left here in the main body of the code here. We've talked about how we get the command line options and how we use those options to construct a query document. You can see here how we're specifying the projection document. Note that we're excluding _ID, but including the name of the company, the founded year, the number of employees, and the Crunchbase URL. Everything else is excluded. We call find synchronously, passing the query object and the projection object, or query document and projection document. And with that cursor then, we call the forEach method on the cursor. Now again, remember that forEach takes two functions as parameters. The first function is the one that's used to iterate through the documents. The second function is the one that gets called if there's an error or when the cursor has been exhausted. This gives us a way of doing some cleanup or some other exit sort of work that we'd like to do when the cursor is exhausted. In the iteration through the documents matching our query, I'm keeping account of the number of documents that matched. Note that we initialized that variable here and set it to 0. This variable is in scope for this callback. And then when the cursor is exhausted and we hit this function here, forEach will take care of calling this callback for us. We simply check to see whether there was an error. And finally, print out those last two messages we saw. One being whatever the query object was, and then the number of documents that matched based on this count that we maintained here. And finally, we close the database and exit our program. So the last piece to explain here is just this. JSON.stringify is a convenience method that allows us to pass an object. This method will generate a string representation of this object. Now, there's just one more thing that I want to show you here, and that is, if instead I don't exclude _ID, let's take a look at what our output looks like. This is a minor point, but something I want to call your attention to because you're going to see it and you're going to wonder. _ID, if we take a look at how it prints out, we see that this is just a big hex string, but it does look a little bit different from what we're used to seeing in the Mongo shell. So if I go to the Mongo shell and do a query where I look at only _ID values, as you remember, we always have this representation of the object ID. Note that it's got the word object ID with parens enclosing something that looks very much like what we're seeing here and here and here. There is no difference in terms of the value type itself. The only difference is in how the shell chooses to stringify or create a string representation for object IDs, and how JavaScript or the Node.js driver chooses to stringify object ID values. This is just a printed version of an object ID from the Node.js driver, and this is a printed version from the Mongo shell. Same value types, just a different way of printing them out. That wraps up our first look at doing things a little bit more programmatically within a MongoDB Node.js application. And along the way, we looked at using some query operators and how to construct query objects from variable values within our application.